Hi guys, and welcome back. Yeah, that was a bit of a crazy weeks. I really wanted to post it a lot more videos, but I haven't been much up here. But that's okay. Yeah, and then you also don't feel like finishing some of the projects, so I'm just gonna show you what I'm working on and what I didn't finish because I just didn't have the time. For instance, I have here this Septronic, and I bought it very cheap. And the funny thing is it really looked a little bit like a Fluke, and even the serial number, if you look, it's a 2010A. Well, that is also what Fluke always uses, these type of numbers. So that was funny, so I just wanted to see what it looked like inside. It did switch on, but it didn't give proper measurements. But yeah, if you can see, it's really there. Even the PCB board says Subtronic, so it actually is a brand. So it's not that it's a rebranded Fluke. Pity. But I found the problem in the DC converter, and I see there are those Tantal capacitors. So that probably needs to be replaced. But I didn't feel like doing that, so we move on. But at some point, this will be done. And another one, this is, I never saw one before, and it's this from the brand Shoe, Shoe, I think. It's German, it's the ASM 5007, and it is a multimeter. It can also measure frequencies, and it does up to 1000 volts. Yeah, the thing I didn't understand is why they put the BNC connector, especially if you want to do AC faults, because you completely stop it from floating. And I already had to look inside, and it's really connected to the earth connection, so that would be a bit tricky if you're gonna measure on the mains. And also I didn't understand why they did that, because the front is actually plastic, so it could still have been floating while you use the BNC. And here you have the earth connection, so you can earth it when you want, no? But then they made a connection between those, and then it's all stopped being floating. So that's a pity, but it is kind of a cool machine. And I didn't find too much about it, but in the radio museum, I cannot share the documentation, they are all freaky about it. But in the radio museum, I found an ad, and it says that it could withstand up to 20,000 volts. It said something like 20,000 volts laat mich kalt or something. So it's not sweating if it gets 20,000 volts. It doesn't mean it can measure it, because it can only measure about 1,000 volts, which is still a fair amount. But it's protected. So they put some big Zener diode that will probably explode, and it protects the meter. We can see if we switch it on if it works or not, and if it doesn't, we just move on to the next project. Also I bought some other things. This is actually a frequency counter. It's from OPTO-8000 Inc. So it is, I think, from the US, and I didn't pay too much also for this one, but it actually looks a lot better than I thought. Well, it's dirty because it's old, but it's all aluminium, and it actually looks quite good. And I did see some sort of DC connection in the back, so the 110 volts doesn't need to be a problem, because I just do like this and put the power adapter in the back. And there is a little hole here to adjust the oscillator, so that could mean that it is just a little bit better than a standard crystal, but I don't know, I didn't open yet, it just came in. So I like to see, we can do this today also to see if that works. And I also bought some sort of splitter. It says Cellway. It's around 800 megahertz. So I think it was, well, Cellway could be from mobile telephone, but it's a low frequency, so it's one of the first GSM version, G2, G1, I don't know. But I just like the box because it has one BNC here, It has 6 BNCs there, so I could put a distribution amplifier, or maybe I put in, if I want to do testing, I put in a breadboard, and then I can make a divider or a prescaler. I'm just gonna play with it. It looks passive because I don't see a power connector anywhere, but it could also be, of course, that it just does like you put just DC also in there. So I don't know that. We're gonna have a look also. And I found, that is very nice, I found here a digital multimeter, and it's from PicTech, and the guys from PicTech are great. I just sent them an email. I just responded on the, they have this contact form on the website. It's the PicTech Germany. And I asked for the service manual, and they just sent it to you. And I remember that also from this PicTech. This one I already have for a while. It is the oscillator is not that good, so the frequency counter is not spot on. So we're gonna have a look at this, replacing the oscillator. But this one is cool because it has just the value that you're measuring right here, and then you have here the tree. Yeah. So if it starts to measure, it just goes here, 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 and you can put it on average or on min max. That looks very cool. So we're gonna, it's working. So we're gonna put also a review on that. And just this just came with it. I think I paid €10 for this frequency counter, and it does work. I only need to clean it and adjust it. So we also gonna do that. So that was a lot of talking. Yeah, let's just have a look at this. Just pick this one. We have a look at this frequency counter, what it does. So we are back with this American OPTO electronics, the OPTO-8000. Well, everything with a lot of zeros sounds interesting. So I think it was around the 2000 area, because then everything was 1000, 2000, everything with 1000 sounded cool. So if I would make a guess, it's around 2000. But it actually looks quite nice. I hope I can put the light. No, that doesn't work. So I will zoom in a bit. But as you can see, it's nice power on off, and now I'll zoom in. Doesn't work. Okay, here we have it. Well, if you can see, it all says Opto Electronics. It has a nice gate light, so that probably will be blinking if we can switch it on off switch. The switches look all very stable. It can do 60 or 600 megahertz. So we're gonna try if it works, if it still goes to 600, or again we can maybe push it to 800. I don't know, I haven't tested yet. There is an attenuator switch on the low channel. The low channel is 1 mega ohm, and the 600 megahertz is 50 ohms, as you usually find. The attenuator switch doesn't feel that good, so okay, that I don't know if that still works. It doesn't feel good. It has a stand, as you can see. That's always very nice. It is very high for the size of the thing, but you can also do without. And if we look at the back, and I really like the quality of this aluminium, really. I don't know how you call it, anodized, I think, because it is not painted, because then you would have seen that the paint goes off, but it isn't. So I like it. It seems good quality. Well, there is a big fuse here, and this looks like a DC plug, so I hope this is gonna save us. So let's see. Oh yeah, and here is the adjustment of the oscillator. So we're not gonna use this. I don't have 110 volts here in my lab, and yeah, it's also not needed if we can use the DC. So let's try to open. Okay, here it is. We're gonna try it using the DC. I did find the manual just now on the internet, and it is not from the 80s but from 78, so I was kind of close. I said 2000, by the way. No, it's a lot older, and it does have a proper temperature compensated oscillator from 0.1 ppm. So that is not bad at all. The DC connection does between 8 and 16 volts, so it probably runs on 9 volts, so I will not put in too much. Yeah, let's open her up. You can see I removed my my dark protected layer because I really didn't want to. It shows a lot better. This underground. I need to find the correct screwdriver because yeah. I don't want to damage the screws. Okay. It really looks nice. Look at this. This is some good quality. This looks a bit weird, what they did here. Why it is all... maybe it fall. Look at this. This is... the board is not straight. It just... I think they did modifications, to be honest. Because the oscillator is not here in the back, it's actually here in the bottom, and I fitted the big one, and that's why it doesn't fit anymore. I hope you can see. It looks a bit messy inside, so I hope it still works. And you can have a 220 volts transformer, but you can also have the 110. So I'm not sure which one this is. Yeah, but just let's try to use the DC. I took also out the bottom. As you can see, it did have some modifications here on the bottom also. Or it was just, it came like this. Well, here you can see it's a proper TCXO. It doesn't run on 10 MHz, but on 5.24288. Yeah, well, in the end it doesn't matter now. We're just gonna look at the end result. Yeah, this is the power supply. This is the pin in. So let's just put DC. Well, I should have my DC 12 somewhere. Yes, here. So let's just do that. I connected this also to my lab 12 volts. So and let's see. No, it doesn't fit. What type of regulator is this? It's a 5-volt regulator, 7805. So this is the pin in then. Okay. It just runs on 5 volt. Then I don't need to put in 12 either. Let's get some power. This should be 5 volts. Get my cables. Okay, I put the Farnell on 8 volts because we will have some drop in the 5-volt regulator. I'm doing 8 volts. And yes. We did see a little drop, but it's probably the caps. So yes, it switches on. That is a good start. It does need some cleaning, but it does look good. Here is the gate time, 100 milliseconds, and here it is a second. It seems about right. So let's see what we have if we put in 10 megahertz. This looks very promising. I just take it from the... let me take it from this one. Now we'll put my Marconi because I want to put first a lower input, and we set it to RF generator frequency. We start with 10 megahertz, and the level we put to be, I usually test with 50 millivolts because I think that is, yeah, and it does. Perfect. And the oscillator is still stabilizing because we just switched it on. So we're just gonna leave it a bit, and then we start adjusting later. But that looks good. Does it also work on the other port? This port should be working up to 60 megahertz. So yes, it does that. And here we have lead 0 or suppress. Okay. Yeah, I don't mind too much. Okay, let's see if we go up. Let's put it fast. Hey, on the 600 megahertz. Ah, here it goes. It just okay. 500. Above 400 megahertz, it really starts to lose sensitivity, and I really need to put in around 200 millivolts. We can look at the specifications if that is by design. Usually I do 50 millivolts with all the modern frequency counters to see how high they go. But even my Marconi doesn't put more than 225 millivolts. That's the maximum I can have in the output. This one also does 0 dBm. Yeah, I kind of stop at 500. Maybe I can put a little bit more, but the sensitivity really starts to drop. $550, $560. Yeah, here it goes. After 560 it just loses. So we can see if there is some amplifier in the circuit and we need to put a little bit more power. If the attenuator works only on the first port, so that's not it. Oh well, let's see. Well, I was able to calibrate it with a little screw in the back. It was a little bit complicated, but because I couldn't get my my plastic screwdriver there in the corner, so I use this normal little screwdriver, but that means you need to adjust, let go, adjust, let go, adjust, let go. Well, in the end it worked, and here we have it, 10.00000, and I did the same in 200 megahertz just to see if that setting also works. I need to switch over to the other board and switch over, and also we have exactly 200. So I would say calibration was a success, and now I'm gonna clean it. I have one of these adapters left from my GPS DAO or the other green boxes. So let's connect this one to the frequency counter, and then we just have 230 volts. Look at this. I think we did a great job. It really looks super clean. It is calibrated. It's exactly 10. And we put a DC plug in the back, so it can just run easily. So that was it, the Opto Electronics OPTO-8000. Yeah, it was 110 volts. There was a DC input, so we just made the DC input there. It only took a little bit to clean, and I still had a DC adapter, so it was very easy to adapt the result. Thank you for watching, and I hope to see you next time.